Now let us discuss about context-free grammar, CFG. It can be denoted by capital G. So basically this context-free grammar has 4 tuples, namely V, T, P, S. We can represent it via V or N. So basically V or N is nothing but the non-terminal symbols. Non-terminal symbols in the sense of capital letters. Terminal symbols means small letters. So V or N represents the capital letters. T represents the terminal symbols, which is nothing but small letters, special characters, numbers, etc. etc. So this T represents the terminal symbols. So P is nothing but the set of production rules. So for example, S gives capital A small a. This is nothing but left linear grammar. S gives A capital A, which is nothing but right linear grammar. If we get a non-terminal symbol at the end, then it has to have another production. So A gives B is another production. So basically this is one production, this is one production, this is one production, and this is one production. We can take this as one example and this whole thing as another example. We have terminal symbol here, so one production is enough. We have non-terminal symbol here, so we need 2 productions. Also we have S over here, right? It has to be non-terminal, which is nothing but we always need to have capital letters over here. Okay, so left side only non-terminal symbols are allowed. If the production ends with a non-terminal symbol, then we should have another production with this alphabet. So when it ends with capital A, we have another production, that is A gives B. Now let us discuss about the derivation trees. Basically we have 2 types of derivation trees, leftmost derivative and rightmost derivative. For example, we got that E gives E plus T or T, which is nothing but E gives E plus T and E gives T. We can write it like this. Depending on the grammar, we can use whatever production we want. So T gives T into F or F, which means T gives T into F or T gives F. T gives epsilon or ID. ID is nothing but identifier. So we can either write T gives epsilon or T gives ID. The string is ID plus ID into ID. So first we have to take E gives E plus T and then we have to solve to get the string. Okay, so now for the first production that we took is E gives E plus T, this one. So just think about it. We have to derive this ID plus ID into ID. So how do you think we can write this E as? This is leftmost derivative, which means we have to solve it like this. First we have to solve all the left terms and then go to the right terms. Coming to the rightmost derivative, we have to solve the right terms and then come to solve the left terms. Okay. E gives E plus T, right? So this E can be replaced with T because E gives T, right? So we have E gives E plus T, and now we have, by replacing this with T, we have E gives T plus T. What do you think this T can be replaced with? F. Because if this E gets replaced with T and this T gets replaced with F, then we can replace this F with ID, right? That is how we'll get this ID. So first we'll replace E with E plus T, and then with this E with T, and now this T with F, and now this F with ID. So we solve the left one. Now let us go to this T. How do you think we can derive this T? If we take this T as F, next we'll get F as ID. So what will it become? ID plus T if we take it as F directly, and then we'll get ID. So we'll get ID plus ID. Is that what we want? No, we want ID plus ID into ID. So what we'll do is we'll take T as T into F. We'll use this production. So ID plus T into F. Now again it is leftmost derivative, so we have to solve this T first. Now this T can be replaced with F. This F can be replaced with ID. Next we have this F, right? F can be directly replaced with ID. So finally we got this answer. Now we have to draw the parse trees. I'll tell you later. I'll tell you about that later. Now let us solve this RMD, rightmost derivative. So we have E gives E plus T. So what do you think we have to replace the T with? Just check this. What did we replace it with? We replace it with T into F. So replace it with that. Next, F. What did we replace that? F with ID. So replace that F with ID. Now we have T. What did we replace this T with? We replaced it with F. Replace it with F. And then we replaced it with ID. Replace it with ID. Now what do we have? We have E. What did we replace it? E with? We replaced it with T. So replace it with T. What did we replace it? This T as F. Replace it as F. What did we replace this F as? We replaced it as ID. Replace it as ID. So at the end we'll get this production. We'll get this string. That is what we wanted, right? ID plus ID into ID. Now let us talk about the parse trees. Also, before that, I want to tell you that the parse tree of LMD and RMD is same. Because at the end, we got the same string and we are just doing the same operations but in a different manner. Here, we are trying to do it from the rightmost element. Here, we are trying to do it from the leftmost element. So, coming to this, now let's discuss about this parse trees. So, E gives E plus T in this particular production, right? So E gives E plus T. E plus T. Take each one as a node, including the addition symbol. Now, how is this E replaced with T? So E with T, and then T with F, T with F, and then F with ID, F with ID. And how is this T replaced with T into F, T into F. Next, T as F, F as ID. T as F, F as ID. This F as ID. Here also we did the same process, right? But in a different manner. So the parse tree is going to be the same. Okay. So let us look at another example. Here we got three productions. S gives A1B, A gives 0A or E, B gives 0B or 1B or epsilon. So what is the string that we need to get at the end of the day? 0, 0, 1, 0, 1. So let us start with the first production. S gives A, 1B. How do you think this A can be replaced as? It can either be replaced as epsilon or 0A. But the first character of our string is 0. So we'll replace it with 0A. Okay, now we have another A. What do you think we have to replace it with? We have another 0, so we'll again replace this A with 0A. So we replace this A with 0A, and now we replace this A with 0A again. Okay, now we have A again. What do you think we have to replace it with? 0A or E? I mean epsilon. We are already done with 2 zeros and we need a 1 right now, right? But we don't have 1 in this production, so we have to replace it with epsilon, because we can ignore the epsilon when we get the final string. So we'll take it as epsilon. Now we have 1. Just leave it as it is. We have B right now. So what do you think we have to replace B with? We already got this one. Now we need 0. So we will replace B with 0B. We'll replace B with 0B. And now we have another B. We got the string till here, 0, 0, 1, 0. We just need 1. So we'll replace B with 1B. We got this. So we got 0, 0, 1, 0, 1. Now this B is extra. We can replace it with epsilon. Here, 0, 0, 1, 0, 1. Same goes with RMD. Just like we did here, we can do it in a different manner. Same, parse tree is gonna be the same for this. And look at the another example. I won't explain this, but I'll just let you know one thing. We have this braces, right? We have to consider these braces as a child node also. Okay? Thank you.